that what is the difference between a throws and throw keyword. So we will discuss over here that what is a throws keyword. So Java throws keyword is used to declare an exception. Okay, so why we require this throws keyword? That was throw was explicitly throwing that particular exception. Okay, but we use this throws keyword to declare an exception. Okay, so the first differences between these two things is that throw simply throw was explicitly defining that particular exception. Okay, and we use this throws keyword to declare an exception. So it gives an information to the programmer that there may occur an exception. So it is better for the programmer to provide the exception handling code. Okay, so it can check for that particular code, that is by executing that code in the normal that is try catch block. Okay, so exception handling is mainly used to handle the checked exception. So if there occur unchecked exception, then what will happen? So okay, so in that particular case we use this throws keyword. Okay, so what is the syntax for that particular throws part? That we have a return type over here, there is a method name, throws keyword we use, and we define the exception class. Okay, so this is the, I will discuss with you the differences also, but you just understand the syntax for this particular case. We have a return type, method name, throws keyword, and the exception class. So four things are required if you want to use this particular throws keyword. Okay, so throws keyword is there. So when we are using this throws keyword, you have to define the return type portion. Okay, method name, this is the second portion because throws is always used with the method part. Okay, and then you have, then there is a throws keyword, this is the third portion, and the last one is your exception class. And inside this particular code blocks you have to define the method. So again I will show you one example. So when you there is one thing that you must understand, that we, as you know, that we have two types of exception, checked and unchecked. Okay, so checked exception are handled at the compile time. That will force you to handle them. If you don't handle them, then there will program will not compile. On the other hand, we have an unchecked exception, that is a runtime, that doesn't get checked during the compilation. So throws keyword is used to handle the checked exception. This thing you must clear in your mind, that when we require this throws keyword just to handle the exception at the that will handle the checked exception. That means it will be handling all those exception at the compile time. So it is required. Okay, it is required to handle all those exceptions. Otherwise, your program will not be compiled. Your program will not be executed. So why we require this throws keyword? Throws because we can declare multiple exception in a one go. Okay. So now there is another question, that what is the need of having that throws keyword when we can accept and all those exception you using that try catch block. Okay, so throws also do the same thing, but there are some cases when you prefer throws over try catch, because what will happen, like that we can have arithmetic exception in, like let's suppose there is a case we have more than one type of exception, like arithmetic exception is there, null point exception is there, so we have to use the try catch block again and again. Okay, so sometimes it is quite difficult, it's quite tedious to write all those try catch for each method. Okay, so unnecessary the complexity of code will be increased at that particular case. So in that case we require the throws keyword. Okay, so again and again what will happen, same throws work same as that of try catch, but what is the difference, that we use try catch again and again with a particular method, but when we are using this throws keyword we declare that particular exception with the method signature only. Okay, like this you have seen over this now, that we are using this throws with this method only. So there is no need to write all those try catch statements again and again. Clear? So this is why, this is the reason that why we you prefer to use throws keyword when we have a multiple exception in a particular program. Okay, so second advantage is that you need to handle the exception when you will call that particular method. So you cannot ignore that particular exception in a particular method. This is the second reason. First reason was that we use this throws with the method signature itself, so it makes the code less complex as compared to the try catch, because using try catch we require multiple lines of a codes are there. Okay, so that may make our program more complex in case if we are having more than one exceptions in a particular code. Second advantage is that when you are using a particular throws keyword with that particular method, so it is required to handle that particular. You cannot ignore that particular exception over here. Okay, so that will be helpful in order to make your code more compile efficient at the compile time. Okay, so there is an example again I will show you regarding this throws keyword. Like here you can see the example over here. We have a throws one. This is the name of my class. In this, what I am doing over here, that again, see, if you remember the code, I am just showing you that code, this particular slide, so that this should be clear in your mind. So you can see the code over here. Okay, so this is the code. You just see, I just want you to clear the syntax, that how we can write this throws and throw. Okay, so we have a simple throws class over here. Okay, so what is the method? That is return type method name. Okay, so in my case, what is the return type? Integer. Method name is the division. Okay, this is your method name. Again, what we are doing, we are passing all those parameters. Like over here we have a parameters like int a, int b. Next is the throws. This is a keyword, third part. And this is the type of exception we are having, exception class name. So what is the exception class name over here? That is the arithmetic exception. Clear? So this is how we are directly using this throws keyword. So in my case, I am using this, I am just showing this, the usage of this throws keyword with the help of a single exception only. So you can tell me that you can see that we are using this throws keyword just to declare that particular exception. Okay. So what I want, that int division, int a, okay, int is a return type, like here. This is a return type. Division is a method name, and we are passing all those parameters, throws, and the type of exception, that is the arithmetic exception. And here is your block of code. Now what we will do, we will see over here that we will create the object of this particular class, and we are passing that values in that particular method. So what we are doing, object dot division 15 comma 0. So 15 value is given to this a and 0 value is given to this b. Okay, so we are handling, we have to handle this particular exception. Why? Because when we use this throws keyword always work with the checked exception, and checked exception are checked at the compile time. So we need to check, we need to solve that particular exception at the compile time by using this try catch block, so that the execution of program won't halt at that particular place. Clear? So we are, what we are doing, we are just trying that particular method over here, like we are passing all those value, and if we see that what type of, if that particular exception will be handled, it will pass this particular step. Okay, so let's see what will happen when I will execute this particular program. So I'm writing Java C. So we have throws one dot Java. Okay, you see the output. So just have a guess that what type of a output we are. Again, now your exception was there. Okay, You have declared that particular exception using this throws keyword, and you have handled that particular thing wisely. So this message will be there. You shouldn't divide by 0. See. Okay. So I hope that this particular thing is clear to you. If you see the output of this particular throw one, so that was telling you that you are not supposed to move further when while your particular error is in their program, or the particular exception is in their program. Okay, students, this is clear to you. So this throws and throw is clear to you. This somehow are some tricky. These statements are this both of these statements are very tricky. So on the very first hand, you might feel some of the confusion. But if you thoroughly implement this all these programs, then there will be no problem. The concept is simple. So are you clear with this particular thing, or something like you have gained some knowledge about this throws and throw? So there is another PPT I will show you that will help you to see that. Okay, so there is a difference between this throws and throws. So that I think this PPT will help you out to understand both the concepts more easily. Okay, so throws and throws in Java, how we can define this term. So throws clause is used to declare an exception, which means it works similar to the try catch. So this is the very first difference, that it is used to declare an exception. So it works similar to that try catch block only. But what is the difference, that when we have a multiple exceptions in a program, so that try catch blocks are quite tedious, quite complex to use all those blocks again and again. So we directly uses this throws directly with the method part. Clear? On the other hand, throw keyword is used to throw an exception explicitly. Okay, so the very first difference must be clear to you, that why we require this throws and throw keyword. Clear? Next is that if we see syntax wise, then throw is followed by an instance. So if you remember the syntax that we have already discussed in the previous PPT, so you can see that throw is always followed by an instance of an exception class. Whereas in throws, it is all followed by the exception class name. Okay. So here we use the instance of exception class, and here we directly define the exception class. Okay, so like here we are reading throw new arithmetic exception. This was the example that we have discussed earlier. So it is with the throw part only that we are defining the instance of this particular case, new arithmetic exception. Okay, so the similar thing when we use with the throws, we can directly refer like this: throws arithmetic exception. Okay. So next is that throw keyword is used in the method body. So that you also understand with the program part, that we use this throw keyword in the method body. So if you remember this particular code of that throw part, I just show you. So you are using that throw keyword inside the method body. This is your method check age, and you are using this throw keyword inside this particular method. Okay. Similarly, but in case of a throws, it is used in the method signature like this, that I have already explained you. You are using this throw keyword with this method. That is a division. Clear? So this difference is very, very important. Many time in the exams, sometimes in the 5 marks question also, this type of a question may occur. Okay, so this is the simple thing that we have already discussed, that how we can use this throws and throw. Okay, so you can throw one exception at a time. So when you are using this throw keyword, that means you are throwing a single exception at a time. Okay, but when you are using this throws part, you can handle multiple exceptions. Okay, so this is the main advantage, that why we require this throw keyword, that we can handle multiple exception in this particular case. Clear? So this is the example that we have already done, that how we can use this throws and throw. Okay. Now the last, if you're clear with this particular throws and throws, I know this is somehow a little new topic to you, but still, if you got some useful information regarding this throws and throw, kindly raise your hand. So I can complete the last part of this exception, that is a custom exception. Okay, clear. Fine, bache. You can again go through all those things. The concept is very simple. Okay. So I have explained you each and everything. The concept is very simple. So as you use in your program, you will able to see that how we can utilize all those exceptions. Clear? So the next thing is that Java custom exception. So what will happen? Till now, you have seen that we are using all those exceptions that are already defined. Like we have a arithmetic concept, exception is there. We are using the instance of that exception in the case of a throw part, or in the throws part. Also, we are defining all those exceptions that are inbuilt. Okay, so all those exception are the inbuilt exception, but there could be some case if you want to create your own exception, or we can say that we have a user defined exception over here. Okay, so that in that case we require the custom exception. So always remember, there is a only last point that you need to remember. Rest thing I will discuss with you help your program, that we pass the string to the constructor of the super class, that is exception. Now, if you remember the very first lecture of the exception, so you have seen that there is a super class exception that handles all those things. Okay, there is only one class, main class, super class, exception class, in which we have all type of exception. Either it is a checked, unchecked, errors, and so on. Okay, so we need to pass the string to the constructor of the super class exception. Okay, so we can handle that particular which is obtained using get message function of the object on the object record. So here we use two things over here, that is the string, that is referring to the constructor of the superclass, that is the exception, and another is there is a get message method that we require to use that particular function on the object grid. Okay, so I just implement one of the program. Okay, so in which I can see that how we can create a custom exception over here. Clear? So I just make one program. So here what I do, I'm just creating a custom exception. So we have a class. Okay, so there is a class. Let's suppose my class name is my custom one. Okay, so this is the class that will represent the user defined exception. Extends exception. So when we use this exception, extends keyword, when we need to inherit something. So what we are inheriting, we are inheriting the class. We are deriving this particular my custom class from this exception class. Okay. So this exception is your inbuilt class. This is the main class. Okay. So I am inheriting, I am defining a user defined class. Okay. Then there is a, what I am doing, I am just defining that particular exception over class over here, that is my custom. Okay, my custom one. and I am passing the string variable, string s. So this is the type of a constructor. Parameterized constructor is there. So in this particular constructor, what I am doing, I am just passing the value. I'm using super s. So I hope you understand the meaning of super s. Super is what? That will inherit all those things. Okay, so this is the call constructor of the parent exception. So whatever the methods that will belong to this particular exception class are inherited in this particular class. That is a my custom one. Clear? So if you are clear with the super part, you must be understanding this particular code, that what you are doing over here, you are just giving a call constructor of the parent exception. This is my parent class, exception class, that is an inbuilt class in Java. This is my user defined class, or we can say the derived class. Okay, so I am deriving my class whose name is my custom one from this particular class. Clear? So this is how I am inheriting all those things over here. Okay, so by using this super keyword, I am giving a call constructor of the parent exception. Clear? Next is that I will define a class that will use my this custom exception. Now, this is how I am defining my custom exception. ठीक है? So मैंने एक अपनी तरफ से I have created my custom exception over here. ठीक है? तो what I will do now, I will use this particular exception. ठीक है? I will use this particular exception in my current program. Now, how you came to know that this is my custom one is type of exception, because it is extending the exception class. Okay, so that's why it is acting as a exception over here. So anything that will extend an exception will itself be a exception over here. Clear? So you can see now I will create another class, okay, that will be using this particular class. So what I will do, I will write like this: class user. Let's suppose I am giving this name user custom. Okay, so this is my class in which I will use this particular above custom exception. Okay, so I have created my own exception over here like this. Simply what I have done, I am just using that string, and with the help of that string, I am using all those with the constructor call, I am using all those method that belongs to this parent class. Okay, so this is the class user custom. What I will do, I will define that public static void main. Okay, so you can see over here. Then I will just try my code over here. Okay, so I will throw an object of this user defined class. So what will happen that in this particular try block, I am just throwing my object, that is new, and what is the name of my exception? That is this one, my custom one, my custom one. In the previous example, we were using arithmetic exception. That was a inbuilt class. Now this is the custom exception. That's why I have my name has been changed over here. Okay, so this is my first exception, my first exception. I can just write like this. Okay, so this is my first exception that you are showing over here. Here, so I just close this particular try block. Now I will handle this particular thing using the catch statement over here, and you can see over there that in this particular catch part, again I will create the object of my exception, that is the user defined exception, my custom one. Okay, so this is the name of my exception. So I created the object for this particular thing. Now in the catch part, I am just handling this particular thing, system dot out dot Okay, so you can see over here that this is the println. Okay, so I can simply write any statement over here. Okay, so I just write like this caught. Okay, so I have handled that particular thing. So this is the main thing that we need to do in that catch portion. Okay, so again I will print my this particular message. Now usually what happen when we have an inbuilt exception, so when that particular exception is handled, there is a message over there. Okay, so we can print that particular message, but like this message we need to print this particular message. Okay, with the help of a get message that I have already explained in the PPT part, that when you want to show that user defined message on the user defined exception, you require to use the get message. So we will use that system dot out dot println. Okay, so I know to print the I want to print this particular message, but with the help of a this object, that is ex dot get message. Okay, so this get message will tell you that how you can handle this particular thing, how you can display that particular message. Yeah, so I'm closing all those things. This is for one casual, then is the public. I think there could be some errors because we're just instantly writing all those things. So I hope everything is clear. So just run this program. So I hope you are clear with this particular thing. I have created, again, I just repeat for you. I have created my own exception over here. Okay. So how I can create my own exception? By extending the parent exception. This exception is your inbuilt exception. So any class that will extend a particular class, so all those features of that class will be same as that the parent class. So this was your exception. So this will also become your exception. That is a what is the name of your exception? My custom one. Clear? Second thing is that with the help of this string, okay, what I am doing, I am just and this with the help of this super keyword, I am calling all those methods that are available in the parent class. Clear? Next is that there is another class, that is the user custom class. So what is the use of this particular class? This class will, what it will do, it will use this customize exception. Okay, so it will use this customize exception over here. So what you have done, you have using this throw keyword in which you will explicitly. Okay, so if you remember the definition of the throw, we usually say that throw, we use this throw keyword to explicitly define the, explicitly throw an exception. Okay, throw new, and this is the name of my exception. This was the name of my exception, that was my custom one. So this is the my custom one. Okay, so I'm just showing you that this is my first exception. Again, in the catch block, I need to handle this particular exception. So I will create the object of this particular exception and I am printing that particular message. That is the caught message. So whatever the message, if you have noticed in the previous exception, so you see that all those messages are the inbuilt message. Like in this particular case, you can see that this all this method are the see all this like this type of a statement is there, that is the inbuilt statement. But in this particular case we want to show our own message. So like I have written caught, so how this message will be displayed using the object of this particular exception. Okay, using the object of this particular exception like this. My custom one was the name of your exception. You have created the object, and with the help of this object, you can pass this particular message. So I just save this program, control S. So what is the name of my class? User custom .java. So I just save this program in this exceptions bar. So you can see over here that I just write the name of my class, user custom dot java. So I think there is some error over here. Oh, this is the spelling mistake over here. So get messages there, and again I just execute this program. I just clear all these things so that the screen is more visible to you. So we have already compiled that particular program. I just run this thing and you will see what type of output we are getting related to this custom exception. See, okay. So caught is the that your particular exception has been handled, and this is the my first exception. Okay, so this is the message that you are passing to over there. Okay, so this is how we are handling all this. So everything is customized. Your message is customized. Okay, your exception is customized. So this is how we can use all these things. Is it clear? I hope you are somehow clear with this thing. That meanwhile you just see that everything that we are used in this custom exception is with the help of this custom that how we can define our own exception, how we can pass our own message. Okay, in just defining portion, just remember that we require a class that will extend the exception class. This is the parent class. Okay, so in that parent class we are just using that super keyword that will handle all those with the help of this constructor part that will handle all those methods that are available in the exception. Okay, and the second thing is that we can throw explicitly throw a message, and we can explicitly define our own message also. Clear? So this thing is quite very important in case if you are interested in programming, in doing so many project large and complex project. At that case you may require to define your own some exceptions over there. Clear? So I hope you are clear with this, because with this particular topic our this exception topic is finished. So are you clear with this particular thing? If you are clear, kindly raise your hands. I know somehow these things are quite difficult, but if you just immediately practice all those things by today itself, then everything will be clear in your mind. These are the one hand things only, that once you will execute all those things, the concept will be clear to you. Clear? So I think now we are over with this exception part. Okay. So firstly, I will just share with you two polls related to this exception part, and after that, I will start with a new topic, that is the multi-threading. So I'm going to launch two polls. Kindly be ready for that. students, there were some issues regarding this poll, so I have just relaunched the poll. Kindly give your answers. Okay, students, I am going to end this poll. Okay, so I am sharing results with you. So the very first question was that which of these statements are incorrect? Okay, so we have to see what were the statements like that. Try block, that try need not to be followed by anything. Okay, so obviously this is the wrong statement. Okay, why so? Because try has to be used along with that this catch block. Clear? So the very first option is correct, and most of the students have given the right answer. And this thing is also required that it can be followed by catch or finally. Try can be followed by final block instead of catch block. So this also may happen. And the third thing is that try need not to be followed by a catch block. Okay, so this is the we can say that this is also one of the correct statement that if we are not using that catch block, we can follow the final block with that. Now, the next part of the question is that which of these clause will be executed even if exception are found. So throws, finally, throw or catch. So if you have gone through my video, in that case, I have clearly shown that finally is such a block that it will be executed. Okay. So either exceptions are there, either exceptions are not there, or either exceptions are there and you haven't handled that. But so finally, it's such type of a block that has to be executed. Okay. Now I will share with you another poll, second poll. Okay. So get ready for that. I'm going to launch this poll. Yes, Kunal, any problem? Kunal, any problem is there with it?
यस मैम, वो पोल बीच में क्लोज हो गया था.
Okay, students, I am going to end this poll. Okay, so I will be sharing results with you. So you can see over here that which of these keywords is used to generate an exception explicitly. So obviously we require throw. Okay, throw is the keyword. So most of the students have given the right answer. So this must be very much clear in your mind that we require this throw keyword to generate an exception explicitly. Explicitly means that we are self-defining that particular exception. Okay, the next part is that this is a simple code that what will be the output in this case. So if you see that we are trying but there is nothing to try that which block we need to execute, and we have a finally block with that particular thing. So no, there is no error of code or there, and there is no statement that we need to check about, but still your finally block will be executed. So that's why your answer will be finally. Okay, so this was regarding that, and most of the students given the right answer, that is finally. So I'm going to stop all these polls, and after that, we will just start with this another topic in Java, that is multi-threading in Java. Okay, so what is multi-threading in Java? So multi-threading, if you remember the concepts we have already discussed in the operating system also. So if you remember your last operating system parts, in that case also, many times we have discussed it, that multi-threading, multi-processing, all these works. So multi-threading means that a process in which we are executing multiple threads simultaneously. Okay. So what basically a thread is? First of all, first question is that what basically a thread is? So thread is a lightweight sub-process, or we can say that smallest unit of processor. Okay. So why we require this multi-threading over here? Just to use, just to achieve that the concepts of that multitasking. Okay, so why we require this threading portion, multi-threading and multi-processing is there, just to have a multitasking. So what we mean by multitasking, when at a time more than one task are being executed on the system. Okay, so why we use multi-threading than multi-processing? Why? Because threads share a common memory area. Okay, they don't allocate separate memory area. So in this particular case, they will save the memory. Secondly, context switching between the threads are or takes less time as compared to the process. So if you remember your some of the concepts, or if you're not clear, you can go through, you can brush up your mind. Where we have already discussed all those things, that why, what is the difference between threads and a process. So thread is, first of all, is main advantage of threading is that you can use this thread can share a common memory area, and it saves a memory. Why so? Because the context switching between that in the case of a threads takes less time as compared to the process. So what role of multi-threading is in Java? So mostly when we are interested in making games, animations, or any type of a, we can say that modes in which we require smallest, we need to notice the smallest execution in the program. In that case, we require the concept of a multi-thread. Clear? Next is that what is the advantage? So it doesn't block the user, because threads are independent and they can perform multiple operations at the same time. Okay, so you can perform many operations and at a time, so that will save your time. You don't need to switch again and again to different operations. So threads are independent. So it will not affect the other threads. So if exception occur in a single thread, so they are somehow are different from the another portion. Okay, so they are don't usually don't interfere with another thread. So each and every thread works in a independent manner. Yeah. So multitasking. So why we require multitasking? So multitask. Multi means many, and tasks are the different things, different process that we are performing. Okay, or the functioning. So multitasking is a process of executing multiple tasks simultaneously. So multitasking can be achieved in two types, like process based or thread based. So anything that is process, the multitasking that is being performed, a process based, that is a multiprocessing, and the thread based multitasking is the multi-thread. Okay, so process based multitasking is what? That in which each process has its own address in memory. Okay, so each process have its own address in the memory. So each process will have allocates a separate memory. So it is heavyweight. The cost of communication is quite heavy. Switching from one process to another requires so much time. Okay, we need to save and load each and everything, memory maps, registers, and so on. So thread are the same, share the same address space. They are lightweight, and cost of communication between the thread is quite low. So at least one process is required for each thread. So this is how we can define all these terms of multitasking. Now, what is a thread in Java? So thread is a lightweight subprocess, and it is the smallest unit of processing. Okay, it is a separate path of an execution. Like we have a different process over here. This is a process one, process two, and process three. So thread works in a single process. So that's why in the previous slide also we have discussed that at least one thread require a one process. So but they are independent. So okay, so if there occur exception in one thread, it is not affect the another thread. And they will share a common memory area. Like here you can see that whatever the memory area we have given to this particular process, all those threads will be sharing that same memory area. Clear? So this is how we can use this thread. So we can say that a thread is executed inside a process and there is a context switching between the threads. So we can have a multiple processes inside a operating system. So if you see all this process belongs to operating system. This is your operating system. We have so many processes in your operating system. Okay, and each process will have its own threads. Okay, so each process will be having its own thread. So at a time, only one thread is executed. This is also the main point that you need to remember that at a time we can execute only a single thread. Clear? Now, life cycle of a thread. Again, this is a very important topic that how a thread behaves. Like if you remember in operating system, we have discussed that we have a different process states, but as in case of thread also, we have a different process. Okay, so a thread can be in one of the five states. So according to the Sun microsystem, we have four states in the thread life cycle. That is new, runnable, non-runnable, and terminal. There is no running state. But for better understanding, we describe all those thread states in five form. Okay, so all these five form are all these states are being controlled by the JVM itself. Okay, so we have a new state, runnable, running, non-runnable, and the terminated. So we will just have a review of all these states. Like we have a new state over here. When we this new state, we use the start method. So simply that thread will come to the runnable part. Okay, so it will come to this runnable part. After that runnable part, it will be in the running state. Okay, so when you are with the what method you require for this running part, that is the run method. So once your run method will exits, your thread will terminate. But there could be some case that while running a particular thread, there it may comes under to the non-runnable state. So what could be the condition in that case? There could be a sleep part that you have prompted that particular thread, block on input output. Some of the requirements of the input output are not being met. Wait for a lock. You require some particular lock in order to perform your action independently. Suspend. There could be some situation that you need to stop that particular process or wait. Wait could be for anything for input output process or for some more priority thread needs to be implemented first. So in that case, you can prompt your running portion and it will move to the non-runnable. That is the block. Okay, so once your thread is blocked, that doesn't mean that you cannot proceed further. Okay, so all those things that have prompted that particular thread, they can be released soon also. So like if you're using that sleep portion is there, so once your sleep part is finished, your thread will again come to that runnable. Input output complete is there. Okay, yes, some requirement for the input output was there, that is being done. Lock available is there, resume is there. Okay, and notified is there, that you have notified that you are completed with this particular process and you can move again back to your runnable. Clear? So this is how these are all the states that we require in the threading portion, and why we require all these sets that are required. So you just simply keep this statement in your mind that why we require this thread function. Okay. So just go through this diagram. Just remember all these things. Okay, clear? So now we can move further. Again, this is a simple explanation. You can read it afterwards also. So thread is a new state if you create an instance of a thread class. Okay, but before the invocation of the start method. So new, in the case of a new, no method is being run. Okay, so just before the start method, you are in the new state. So runnable is what? When you, after the invocation of the start method, when you have used that start method, at that case, your thread will move from the new to the runnable part. Okay, but in this particular case, thread scheduler will not select that thread scheduler has not selected it to be the running thread. So you are just preparing that thread to run. Okay, so that is the start method, and running means the thread is running state if the thread scheduler has selected. So when thread scheduler is what, that will tell us that which particular thread will run. Okay, so this will be in the running state when then start scheduler will decide that particular thing. Block state is that when the thread is still alive, but it is currently not eligible to run. Okay, so that is the block state when you are prompting something. In that case, we require. So in that case, non-runnable doesn't mean that thread is lost or thread is dead over here, but it is alive, but currently it is not being running. It is being prompted. Okay, and the last is the terminated one. Now this is the important thing that how we can create a thread over here. So you just remember that there are two methods to create a thread. Okay, so one is your by extending the thread class. So obviously, if you are using a thread over here, so that means you require an inbuilt class also. So that is a thread class. So there are two methods by which you can create a thread. One is a extending the thread class, and the another one is the implementing the runnable interface. So I hope you understood the term interface. So that is the runnable interface over here. That is by implementing the runnable interface. So we will discuss each and every method. So before that, so before you just understand that what basically a thread class is. Okay? So thread class provides you all those constructors and the methods which you need to create and perform operations on the thread. So thread class extends object class and implements runnable interface. This thing you must remember. Thread class extends object class. So again, object class is the parent class to this particular thread class, and it will implement the runnable interface. So some of the commonly used constructors of the thread class are thread, thread with string name, thread with runnable R, thread with runnable R, and the string name. So all these are the constructor. We will be using all those things in the one or the another way in our programs. So you just remember that we have a commonly used constructors over here. So we have a default constructor as a thread, or we have a parameterized constructor with one parameter or the two parameter. So commonly used methods of the thread class. Now again, this slide is very important. We will be discussing all those methods in our program. So the very first method is that run method, that is required to perform action for a thread. Start, that will start the execution of a thread. So JVM calls the run method of the thread. Sleep is there, that when we cause the currently executing thread to sleep, or it will prompt that particular thread for a specific time. Join, that will wait for a thread to die. Okay, so with a this particular join with a parameter long will that will die for a particular specified time. Priority, get name, set name, current thread. So all these are the different methods of the thread class. We will be discussing each and every method in a we can see that we will be discussing all those methods of this thread class one by one through our examples. Okay, so in this particular today's lecture only we just see that how we can create a thread. Okay, so now there is a runnable interface also that we have already discussed. That one method is that we can extend the thread class. Another one is that we can implement the runnable interface. So runnable interface should be implemented by any class whose instances are intended to executed by a thread. So I hope you are clear with the interface part, that why we require interface portion over here. So for an interface, always the implementation will be provided by the class over here. Okay. So it is implemented by a class whose object are intended to be executed by the thread. So we will implement all those methods in the interface. So just remember one thing, that runnable interface have only one method, that is the run method. Clear? So you just remember this particular thing. In this part, we have all those methods in the thread class. Run, start, sleep, join, priority, get name, set name, current thread. But runnable interface mean we have only a single method over here, that is a run method. Clear? So you can just for a minute you just go through all these methods that we use in the thread class. Okay, and after that there is only single method, that is a run method. Okay, so starting a method, how we can start a method? That start method of a thread class is used to start a newly created thread. So what this start method will do? It will start a thread, okay, with a new call stack. It will create a stack. The thread moves from the new state to the runnable state, not running state. This thing you must remember. Okay, so thread moves from new state to the runnable state. When the thread gets chance to execute, it target the run method will run. So when you use this run method, then only it will come to the running part. Okay, so what this start method will do, it will start the new thread with the new call stack. Call stack means it will create a stack over here that will help you that what to run at what time. Okay, so if you now I will start with this program, that how we can create a thread. Okay, so we can have this example over here. The first method was that we can extend the thread class. So the first method, by first method we will discuss that how we can extend a thread class. So we can have like this. We have a class. Let's suppose I'm using class th. This is a newly class that is extends thread. Okay, so I am extending the thread class. This is the first method by which we can create a thread. Then we have a public void. Okay, so this is a public void run. Okay, so this is why we require this run method, to run a particular thread over here. Okay, so we can write like this, public void run. So we can simply print the statement over here, system dot out dot println. Okay, so this is one of the, again there is a thread is running. So we are just, thread is running. I am just simply passing this statement over here. Okay, so after that what will happen, I just close this particular method, that is the run method. Now I will use this particular thing in my main part, public static void main. Okay, so I just, and you just see that what is the name of my class, that is the t1. This is my first thread. T1 is my first thread, equal to new th. Clear? So I will just start this particular thread, that is T1 dot start. Okay, so this is how we can create a thread. Simply what I have done, I have created a class th that is extending the thread. My first method is that we can directly extend the thread class. I use that run method over here. Why so? That run method will be automatically running. Okay? So we don't need to call that particular run method over here. So it will be automatically running. That thread is running. That will show you, in order to just show that my thread is running, I have passed this statement. Okay? So with this class is also a thread class because it is extending the thread class. I have created one object over here. With the help of that object, I will use the start method that will make that newly created thread to the start part. Okay? So this was your new state. Okay? New state is what? When you have created a particular thread. T1 dot start is the runnable state. It is not running, it is a runnable state over here. And run will be your running state. Okay? So if you see, I just save this program, that file. I'm just save this program. ts dot java. So I'm just saving all my programs under the same heading. Okay, so I just implement this particular cd multi. Okay, java c. So what is the name? th dot java. T1 dot some error is there. Okay, I've used this too. Okay, I'll just again run this program. Okay, now program is being compiled. Now is just see the execution of this particular thing. See, thread is running. So you just start this thread. Okay, so once you will start this particular thread, automatically your run method will be called. Okay, so that is start is required to make your thread to change from new state to the runnable state. So once it get runnable, it will automatically call that run method over here. Clear? So this is about that how we can extend a class, how we can create a thread by extending the thread class. Now the next part is that we can this was the first method by extending the. Another part is that when we implement using the runnable interface. So again, what I do, I just take my class. So I just give this name th1. Now when we require to implement a particular interface, we require implements keyword over here. So that is implements runnable. Okay, so runnable is the interface that we need to implement. And this particular interface, if you remember, consider only one method only, that is the run method. Okay, and you again simply write like this: system dot out dot print ln. So both the you can follow both the method, but there is only a little bit difference that I just show you after completing this particular code. That what is the difference behind using both the method? Okay, so you simply close this thing. We have a public static void main. Now see, what is the name of my class? th1. Okay, that is implementing that runnable interface. So what we'll do, we will create the th1. Let's suppose this is the name of my object equal to new th1. Okay, so this is my class name. You can see over here. So this is I'm just created the object for that particular class. And now what I will do, now there is a little bit change over here. Like I have to use this thread object over here. That is, let's suppose t1 equal to new thread m1. Okay, then we have t1 dot start. Clear? So this is the difference in the this particular program. Okay. So what we are doing over here, that no doubt we will be create the object of this particular class, but we require a thread class that will pass this particular object if we are not, if we are following the method of this interface portion. So you can see over here that if we are not extending the thread class, okay, then what will happen, that class object will not be treated as the thread object. You can see in that particular case directly we were inheriting the thread class, but now we are following the another part in which we need to implement the runnable interface. So if we are not, if in the case we are not extending the thread class, then a class object will not be treated as the thread object. Like this particular case, this m1 is not thread object over here. Okay, this is not a thread object, this is a normal object. So we need to explicitly create the thread class object. So we are explicitly creating the, like here, using this particular statement, we are explicitly creating a thread object over here. Okay, and we are passing the object of a class that will implement the runnable so that our run method may execute. Is it clear? Why do we require this particular case? Because we are implementing that particular thing using the runnable interface. So if we are not directly inheriting the thread class, so that object will be a normal object. So in this particular case, M1 is a normal object. It is not a thread object. We require a explicitly thread object just to make this particular object as a thread object. How we can do it? We can pass this particular object to this particular. Clear? So this is the only difference, and this is the quite important difference. That why, so we need to pass the object of a class that implements runnable, so that, and why we require all those things, because with normal objects we cannot perform that threading operation, so we require a thread operation. So if you are using a runnable interface, you require to use a particular thread object over here. Clear? So this is how we can implement this particular case. Now again, I just save this program, th1.java. Okay. So when I just execute this particular thing, I just read this java c th1 dot Just wait for a file. Okay, so I just run this thing. It is th1 thread is running. Yeah, so this was all about that multi-threading. Now there is another thing that what we have discussed, that how we can uh, create a thread, what basically a multi-threading is, okay, and why we require it. And another part is that why what is the purpose of all these concepts, that is how we can create a thread over here. Okay, so what will happen now, there is a these are two questions that you need to implement, that what will happen if we start a thread twice. Now let's suppose this is t1 dot start. Now what will happen if I do this like t1 dot. So I think this I must explain when we will do that sleep method over here. That will be more easy to understand. So I just conclude my lecture that by this particular thing only, that how we can create a thread over here, and we can discuss the rest of the part in the next part when we will discuss the thread schedule. Clear? So I hope you all are clear with this term. So this is quite interesting part also. So I need to share two polls with you. So if you felt like that my lecture was quite informative regarding this threading, kindly raise your hand so that I can share my polls with you. Okay. So just revised all those concepts in your paper, and I will try to give you more programs in your lab exercises. Okay, so you can implement all those things, and if you feel like any problem, you can discuss. Okay, now there is another code. It contains only one question, so kindly complete in time so that I can give you another program. Okay, students, I am going to end this poll and I am sharing results with you. So most of the students have given the right answer. Obviously, there are no two states in this thread. We have total five states. Okay, and rest of the statements are the correct one. Okay, and now I will share you with you the another poll. This is the last poll based on this multi-threading. Okay, students, I am going to end the poll. And I'm sharing results with you. So you can see that which of these method of thread class is used to suspend a thread for a period of a time. So we have a sleep method for that, and it is right answer, and most of the students have given the right answer. Next is that execution of a Java thread begins on which method call. So obviously the execution starts from the start method. Okay, so execution gets started from the start method. So this is also the right answer, and most of you have given the correct answer. So thank you very much. So I hope you all are quite get good information about all these topics that we have covered in today's class. So we have completed the exceptions part. So I just repeat it again that some of the topic of the exception I have completed through that videos also, and some of the topics we have already discussed in the previous class, and today itself we have completed two three topics that were related to the exception part. Clear? And we have started with the multi-threading portion, and obviously this is one of the most interesting topic in Java. So from the next time we will start with that, how we can use all those methods that we have already discussed in the thread class. Sleep method is there, create method, current thread is method is there. So we have so many methods that we will discuss, and we will see how we can utilize all those things in the this Java part. Okay, so I hope you all are clear with this thing. So I will just try, like today also we have created, I have implemented 2 3 programs. So I will see according to the time. So if I feel like that some of the programs that I can lively explain or implement all those things, so I will try my level best for the same. Okay, so but otherwise everything will be in the form of a programs only. So nothing, no more theory is there in your this particular. So every implementation is according to the program only. Is it clear? So if you are comfortable, if you are satisfied with today's lecture, so this is a final call to you all. Kindly raise your hand so that I can get a particular feedback that everything was normal in today's lecture. Okay, I can see the hands being raised. So, what about this Harleen, Simranjeet Singh, Manpreet Singh? All are present or not? Yes. So, students, kindly go through today's lecture, and if you feel like any problem, you can discuss with me afterwards. Thank you very much. Thank you for your patience listening.